Unusual evidence for the tired light hypothesis and issues with redshift measurements, a deep dive. Greetings, the crew of the U.N.S.S Phoenix XCS-337. Today, I'm thrilled to delve into a fascinating and somewhat controversial topic in cosmology, the tired light hypothesis and the issues surrounding redshift measurements. As the founder of our space exploration and role-playing group, exploring alternative theories and understanding the evidence that supports them is crucial and incredibly exciting. This blog post will thoroughly examine these concepts and explain why I find the tired light hypothesis particularly compelling. And don't forget to check out fascinating content on KrazzyFrank's Craazy videos on YouTube. Understanding redshift and the expanding universe. Before diving into the tired light hypothesis, let's briefly review the concept of redshift and its significance in cosmology. Redshift refers to the phenomenon where light from distant galaxies shifts towards the red end of the spectrum. This shift is interpreted as a sign that these galaxies are moving away from us, suggesting that the universe is expanding. The most widely accepted explanation for this redshift is the Big Bang theory, which posits that the universe began as a singularity and has expanded ever since. The Big Bang theory is based on the observation that the universe is expanding and provides a comprehensive explanation for a wide range of cosmological phenomena. However, there are alternative explanations, including the tired light hypothesis. The tired light hypothesis, an overview. The tired light hypothesis, a historical overview. Unusual evidence supporting the tired light hypothesis. While the mainstream scientific community has largely dismissed the tired light hypothesis, there are several pieces of unusual evidence that warrant further investigation. 1. Surface brightness of galaxies. One key prediction of the expanding universe model is that the surface brightness of galaxies should decrease with distance. However, observations have shown that the surface brightness of distant galaxies remains relatively constant, which could be more consistent with the tired light hypothesis. 2. Time dilation in supernovae. The expanding universe model predicts that time dilation should be observed in the light curves of distant supernovae. While some studies have confirmed this prediction, others have found inconsistencies that the tired light hypothesis could explain. 3. Cosmic microwave background, CMB-CMB. The CMB-CMB is often cited as strong evidence for the Big Bang theory. However, some researchers argue that a tired light mechanism could also explain the CMB-CMB's uniformity and spectrum, where photons lose energy over vast distances. 4. Anomalies in galaxy formation. Recent observations by the James Webb Space Telescope, JWST, have revealed galaxies that appear more mature than expected for their age. This impossible early galaxy problem could be addressed by the tired light hypothesis, which suggests that the universe might be older than currently believed. Issues with redshift measurements. In addition to the unusual evidence supporting the tired light hypothesis, several issues with redshift measurements cast doubt on the expanding universe model. 1. Measurement uncertainties. Determining an object's redshift requires precise measurements of its spectral lines. However, various factors, such as instrumental errors and interstellar medium interactions, can introduce uncertainties that affect the accuracy of these measurements. 2. Local group dynamics. The motion of galaxies within local groups and clusters can complicate redshift measurements. For instance, gravitational interactions between galaxies can cause deviations from the expected redshift distance relationship, leading to potential misinterpretations. 3. Non-uniform expansion. The assumption that the universe expands uniformly in all directions may need to be revised. Variations in the distribution of matter and energy can lead to anisotropies that affect redshift measurements and challenge the standard cosmological model. 4. Alternative redshift mechanisms. In addition to the tired light hypothesis, other mechanisms, such as gravitational and intrinsic redshift, have been proposed to explain the observed redshift. These alternative explanations suggest that redshift may not be solely due to the universe's expansion. Implications of the tired light hypothesis. Given the unusual evidence and issues with redshift measurements, the tired light hypothesis is a compelling alternative to the expanding universe model. Here are a few reasons why I believe in this theory. 1. Consistency with observations. The tired light hypothesis explains several observational anomalies, such as the constant surface brightness of galaxies and the mature appearance of early galaxies. These observations challenge the expanding universe model and suggest that alternative explanations should be considered. 2. Simplicity and elegance. The tired light hypothesis offers a simpler and more elegant explanation for redshift without introducing dark energy or other exotic components. This theory avoids the complexities of the expanding universe model by attributing redshift to energy loss over vast distances. 3. Open-minded exploration. As explorers and scientists, it is essential to remain open-minded and consider alternative theories. The tired light hypothesis encourages us to question established paradigms and explore new possibilities, fostering a spirit of curiosity and discovery. This open-minded approach is beneficial and inspiring, as it leads to new insights and discoveries. 4. Historical context. The tired light hypothesis has a rich historical context, dating back to the early days of cosmology. Revisiting and re-evaluating this theory allows us to appreciate the diversity of ideas that have shaped our understanding of the universe. This historical perspective enriches our knowledge and connects us to the long tradition of cosmological exploration. Future research directions and conclusion. Despite its intriguing aspects, the tired light hypothesis faces several significant criticisms. 1. Lack of a physical mechanism. One of the most substantial criticisms is the absence of a well-defined physical mechanism that explains how photons lose energy over vast distances. The hypothesis suggests that light tires and redshifts as it travels, but it doesn't provide a transparent process for this energy loss. 2. Inconsistency with observations. Several key observations in cosmology are challenging to reconcile with the tired light hypothesis. Time dilation in supernovae. The expanding universe model predicts time dilation effects in the light curves of distant supernovae, which have been observed. The tired light hypothesis struggles to account for these time dilation effects. Cosmic microwave background, CMB-CMB. The uniformity and spectrum of the CMB-CMB are well explained by the Big Bang theory and the universe's subsequent expansion. The tired light hypothesis does not naturally account for the observed properties of the CMB-CMB. 3. Surface brightness and Tolman test. The Tolman surface brightness test predicts that the surface brightness of galaxies should decrease with the square of the redshift in an expanding universe. This test is based on the assumption that the universe is expanding uniformly. Observations have confirmed this prediction, which is inconsistent with the tired light hypothesis, where surface brightness would remain constant. Olber's paradox. Olber's paradox questions why the night sky is dark if the universe is infinite and filled with stars. The expanding universe model resolves this by suggesting that the universe has a finite age and is expanding, so we only see a finite number of stars. The tired light hypothesis does not provide a satisfactory resolution to this paradox. 4. Gravitational lensing. Gravitational lensing, where the gravity of intervening masses bends light from distant objects, is well explained by general relativity in an expanding universe. The tired light hypothesis does not naturally account for the observed gravitational lensing effects. Check out our website and Discord links in the comments. Don't forget to like and subscribe to our channel. We're growing and producing even more fantastic content. Join us for this incredible adventure, where every day brings new and exciting discoveries. Remember, your role in this journey is crucial. Your curiosity and passion for cosmic exploration are not just important, they drive our mission to expand human knowledge. And remember to subscribe to KrazzyFrank's Craazy videos on YouTube for more fascinating insights and cosmic explorations. Also, keep an ear out for Being Frank with KrazzyFrank's videos on YouTube for more fascinating insights and cosmic explorations. Also, keep an ear out for Being Frank with KrazzyFrank, my upcoming podcast where any crazy talk goes. Ongoing experiments to test the tired light hypothesis. While the tired light hypothesis is not widely accepted in the scientific community, some researchers are still exploring its validity. Here are a few notable efforts. 1. Shamir's study. A recent study by Kansas State University engineer Lior Shamir provided evidence supporting the tired light hypothesis. Shamir's findings challenged the Big Bang theory by suggesting that redshift could be due to light losing energy over vast distances rather than the universe's expansion. This study has reignited interest in the tired light hypothesis and calls for further investigation. 2. Re-evaluation of surface brightness. Some researchers are re-evaluating distant galaxies' surface brightness to test the tired light hypothesis predictions. This involves comparing the observed surface brightness with the projections made by the expanding universe model and the tired light hypothesis. 3. Alternative redshift mechanisms. There are ongoing efforts to explore alternative mechanisms for redshift that could support the tide light hypothesis. These include studying the interactions of photons with interstellar and intergalactic media to see if energy loss mechanisms can be identified. 4. Theoretical and computational models. Researchers are developing theoretical and computational models to simulate the effects of tide light on cosmic observations. These models aim to predict observable phenomena that could distinguish between the tide light hypothesis and the expanding universe model. Observational data supporting the tide light hypothesis. Some observational data has been interpreted to support the tide light hypothesis. However, it remains a minority view in the scientific community. Here are a few critical pieces of evidence. 1. Shamir's study. Lior Shamir, an associate professor of computer science at Kansas State University, conducted an observational study using data from 3 telescopes and over 30,000 galaxies. His findings suggest that the tide light hypothesis could explain the galaxy's redshift rather than the expanding universe model. Shamir's study found that galaxies rotating in the same direction as the Milky Way had a different redshift compared to those rotating in the opposite direction, and this difference increased with distance. 2. Surface brightness of galaxies. Some researchers have noted that the surface brightness of distant galaxies remains relatively constant, which is more consistent with the tide light hypothesis. In an expanding universe, we would expect the surface brightness to decrease with distance, but this has only sometimes been observed. 3. Anomalies in galaxy formation. Recent James Webb Space Telescope (JWST) observations have revealed mature galaxies that appear older than expected based on the Big Bang model. These findings have led some to reconsider alternative explanations like the tide light hypothesis, which could suggest that the universe is older than currently believed. Conclusion. In conclusion, the tide light hypothesis presents a fascinating alternative to the expanding universe model, supported by unusual evidence, and addresses several issues with redshift measurements. While this theory remains controversial, it encourages us to think critically and explore new avenues of research. As members of the U.N.S.S Phoenix XCS-337, let us continue to navigate uncharted territories, gather valuable data, and challenge our understanding of the cosmos. Please share your thoughts and insights on this topic with me. Together, we can deepen our knowledge and contribute to the ongoing exploration of the universe. Clear skies and safe travels, crew. Wikipedia Tide Light, New Atlas Tide Light Universe, Big Think Redshift Issues, Shamir's study, Wikipedia Redshift, Big Think Redshift Issues.